This is real deal, real world. This is how credit cards work, okay? So they tell you a percentage. It's listed as an APR, nominal APR, that's really important, at 24%. But the interest is monthly, which means if annually it's 24% nominal, each month it has to be 2. That's given, 2% per month. I want you to start by doing problems 1 and 2 only with your partner. 1 and 2 only, please. Okay, 3, 2, 1. Eyes on the board. Mouths closed. I see a lot of calculators, friends. I'm just going to point out in the directions. 1 and 2 says write expressions. And then 2 says write an expression. So we didn't need to do any computation, actually. So number 1. Who can help me out with an expression for 1 month? Ryan? To the 1, or you don't have to write anything. So that's 1 month. 2% each month for a year, they're saying, is nominal interest of 24%. So 2 months. Who can tell me what the only thing I need to change is? Susio?
The exponent.
Yeah, what should I change it to? Yeah. 2 months is 2. And then for 6 months, Vinny? And then for 1 year, Troy? Yeah, we got to change it to 12. Okay, so a general expression then, let's do it all together. We got an initial value of 1,000, a growth factor of 0.02 to the m number of months. Excellent. Now, let's go next. What do they go to owe after 1 year without payment? We already wrote that expression, 1,000 times 1.02 to the 12. We're doing these together. You're doing 1 and 2. So 1,000 times 1.02 to the 12th gives me a new value, $1,268.24, which is that's a lot of money. You have to pay back an extra $200 some. Let's say you borrowed $10,000, you'd have to pay back $2,680 extra, right? So, and to put this 24% in context, a common house percentage would be somewhere around 3% interest, and a car percentage would be it's a Tesla. Okay. T. It's 2.5% interest. So the credit card, they don't know what you buy with it, but the credit card interest is 24%. That's pretty significant, in comparison, right? So, but if you pay it off, you never pay percentage. Same as any loan. If you just don't take a loan and just pay.
So you just don't need to pay.
Yeah, that's if you don't pay it off. Yep. So, this next one I'm going to have you tackle with your partner. It's a little more challenging. This one wants an expression for years instead of months. So here's what we've got to do that. We've got to find the effective APR. So I want everybody to make sure you circle or highlight where it says nominal, so you can point to it, and where it says effective. So nominal is at 2% every month for 12 months is 24. The effective is what the percentage actually ends up being with the cumulative nature of it. So here's how we're going to find it.
But if it's 1 year, either way, it's still 1 year. So wouldn't it just be 24% either way?
Well, let's check. Watch this, okay? How much money extra did it go up doing that 2% per month? You started at 1,000.
268.
Yeah, so it went up $268.24. If we take how much it changed and divide by the original, that'll give us the percentage that it changed by, correct? And this gives me 26.824%, which means the annual effective interest rate of this 24% nominal is actually 26.8%. It's because that 2% each month, from month 1 to month 2 has 2% more than month 1. And then the third month has 2% more than the previous month, and so on. So this is what the interest rate ends up being, the effective interest rate. That's the difference between nominal, and you got to be careful. When interest rates are published or put on things like promotions, they might use the lower one to look better or the higher one to look better. You got to know what you're dealing with, right? My personal favorite, I know I saw 2 of them out there. My personal favorite is this: 1,000 times 1.02 26824 to the t. That's my personal favorite, but this other one is really cool. The other one I saw is 1,000 times 1.02 to the 12 to the t.
I did that.
Now, if you wrote this second one, what I want you to do right now, if you wrote the second one, here's what I want you to do right now. I want you to put in your calculator 1.02 to the 12th and see what you get. If you did this, put that right here, just 1.02 to the 12th. Put it in your calculator. I'm going to show you the expressions I used. So I just looked at the growth factor. I didn't need to know the 500 because they're both getting invested the same amount. So I said 1.03 to the 4th, which I got as 1.1255. And I did 1.04 to the 3rd power. And I got 1.124864. So which one is better, 3% 4 times or 4% 3 times? 3% 4 times. And the way I set up these expressions is one's quarterly and one's in thirds. So we have to look at how often it's compounded. So the lower percentage got compounded more often and it ended up being better. They were both, though, as Cam pointed out earlier, the nominal percentage for both was 12. The effective percentage wasn't 12 because of the cumulative effect, the exponential effect of the percentage and growth factor, right? We don't need to build the model. We could, if you wanted to see how much actual money, we could multiply by 500, right? But it doesn't matter. If you're starting at the same, all you have to identify is growth factor difference to see which one's going to be better. All right? So this one deals, it's related with what we're doing because those financials, right? We talked about the cumulative nature of when you borrow money or invest money, right? So this shows it's probably a pretty good model of a college and the college price for tuition. And we're gonna kind of roll through this kind of together, kind of nice and slow. So we've got f of x equals 15 times 1.07 to the x at a college. That's the price that the college has been increasing since 2017. So who can tell me what the price of college was at this college in 2017? Sean?
$15,000.
It's $15,000, the initial value. Okay. And then who can tell me what is the growth? What percentage is it growing at? Okay.
7%.
So 7, and I'm just going to write I and C for an increase.
Right?
Yeah, it's going up 7% every year. Okay. So we're going to assume that back in time is also growing at the same rate. Who can help me write an expression to figure out what the tuition would have been in 2000? What's the expression that I would use? You want to give it a shot, Vinny?
Well, would it just be
So this one's 2017. It's asking about 2000.
you just
Like if it was 1 year, we do an exponent of 1. If it's 2 years, we do an exponent of 2, right?
would you divide by something? Or would you not?
Kinda. What are you thinking, Ryan? That negative exponent, 17 years before. So why I said, Vinny, why kind of true is a negative exponent means reciprocal, which is division, right? So, yeah.
What if you did 0.93 times positive?
No, that won't work because remember that growth and decay depends on the initial value, and that's going to change your initial value. Okay, so what I got here then, the tuition for 2010 when I slap this in my calculator here, is 4.75 thousand. Much cheaper just 17 years before, right? That's what mine was, right, close-ish to, right? I was in college in 2004. When you graduate high school, how many years is that from now? 20, so 10 years, that's kind of convenient. So 10 years from now. So let's do f of 10
Oh, he means 10 years from 2020.
from 2027, sorry. Okay, so let's do that to the 10. So when you graduate, you lucky folks get to have about almost $30,000 a year for tuition. That doesn't include room and board, books, or doing fun stuff like going to sporting events. Okay. So good thing you know how it. You know how percentages work. You could start saving now. All right. So 2 says we notice in those 10 years, what happened? From about 15 to about 30, essentially our tuition doubled.
Nearly doubled.
Okay?
White insane.
So what do you think about 2017 to 2027? What do you think is going to happen?
Doubled.
Doubled. Anybody?
Ireland.
It's going to double. Does anybody have an idea of the most common wrong answer? I'll get there.
It'd be like,
I hear quadrupled sometimes.
no, somebody.
And it's from a good reason. What do we know happens to the difference? Is the difference staying the same each time?
No, it's
No, the difference is doubling, right? So it would be like a quadruple if you're talking difference. But the word double is already a factor. That factor of doubling every 10 years is going to stay the same.
maybe somebody would say
Forever.
9.1.
Okay?
9.2.
It's always doubling. Okay? It's always doubling. Now, here's why this is so important to understand. If 7% isn't that crazy of a percentage, right? Do you guys know that that's probably in the realm of a percentage, or maybe you could do a little better of investments, like average investments? So that means if you could stash money away, what can your money do a little quicker than every 10 years? Double. And if you know that, you can use that to your advantage for things like retirement, home interest, right? Like, it's all about understanding how the numbers are going to work and make decisions. That's everything.